Hello friends, this video on triangles part 1 is brought to you by examfear.com. No more fear from exam. What we will study? We will study triangles, similar figures, Thales theorem, angle bisector theorem and Pythagoras theorem. We'll also study area of triangle. What is triangle? Triangle means tri plus angle. That means anything that has three angles is called triangle. For example, let's take this figure. This figure has three angles. Angle 1, angle 2 and angle 3. You draw any figure which has three angles. For example, this is a triangle because it has three angles. There are various kinds of triangle. We have learned this. One is right triangle where one angle is 90 degree. Then we have equilateral triangle where all the angles are equal, that is 60 degree. Then we have isosceles triangle where two angles are equal. And then we have scalene triangle where all the angles are different angles. These things we know. We know basic property of angle, what is triangle, what are the different kinds of triangles. All these things we have learned in our previous classes. Before I start with a similar triangles concept, let me first give you a hint on what is similar figure and what is similar shape. Look at this. This toy and this toy both are similar. Why? Because the shape is same but the size is not same. This is small size and this is big size. But if you see, shape is same. We'll take one more toy. Here also, this is a bigger size. Bigger size. But if you see, shape is all same. Same shape. Please make a note. Shape is same because if you see the eyes are all same, lips are all same, these things are all same, the color is same, everything is exactly same. The only thing is the shape is same and the size is different. You can also think of this way that this is one object and you zoom in and zoom out. You zoom in, you get smaller object, you zoom out, you get bigger object, right? This is zoom in, this is zoom out. So in case of similar figures, the shape is same but the size varies. We'll take some more example. So this teddy bear, if you see, and this teddy bear, again here the shape is same but the size is different. Here also the shape is same but the size is different. This is smaller size, bigger size, bigger size. Same shape, same shape, same shape. So in case of similar figure, what we are seeing that objects have same shape but different size. We have one more concept in maths called congruent figures. In congruent figures, we have same shape and same size. For example, if you see this teddy, this teddy, this teddy, this teddy, all these teddy have same shape and same size, right? If you see this, same shape, all has same shape and the size is also same. If you see the length and breadth, right, exactly matches. All have same shape and same size. They are called congruent figures. Correct? We'll take one more example. We'll take this bat. All this bat has same shape and same size. If you see, right, the shape is same and the size is same. So they are called congruent figures. So we have learned two terms here. First is congruent figures and the second is similar figures. Correct? So congruent figures that has same shape and same size. Similar figure has same shape and different size, right? But different is not mandatory, but even if you have same size, it will be a similar also. That way I can say that if you see, right, you added one more condition here in congruent figures. Here the condition is little relaxed, that is size may vary, size may not vary, right? So we can say that all the congruent figures has to be similar also, correct? Why? Because the congruent figures are same shape and same size. Similar figures are only same shape, correct? So we have two concepts till now we have learned. One is congruent and one is similar. If I say two objects are congruent, that means both has same shape and same size. If I say two objects are similar, that means they have only same shape but different size, correct? Now let's see some mathematical figures. If you see, right, these are all squares. You see all the squares, and all the squares are similar figure. Why? If you see the square, all the angles are 90. You take any square, all the angles are 90. Correct? Going by the teddy bear pattern we have seen, all the square look same. The only thing is the size increase. The shape is same, right? Shape is same. For any square, the shape is same. That is, all the angles are 90 and all the sides are equal. This is the shape of a square. So, any square, if you have any two square, if you compare those two squares has to be similar. Why? Because both the square, if you are talking about any two square you take, that will have same internal angle and the sides are same. So any two square is similar. We'll take some more example of mathematical figures, straight lines. For example, if you see the straight lines, all these straight lines, if you see, I mean, if you compare the width of a straight line, we don't compare, I mean, we believe that, we assume that this straight line has very thin width. So if you compare these straight lines, all these straight lines are similar figures. They are also similar figures, correct? Only the size is increasing. Shape is same. If you compare this, right, this is shape. The shape is all same, only the size is increasing. So all the straight lines is also similar figure. If we take the example of circle of us, you see, right, all similar figure. Why? Because it has some center, it has some radius, and it is all round. All are all round. So we can see that all the circles are also similar figure. If we take example of equilateral triangle, also, they are all similar. Why? The shape is same, only the size varies. You take any equilateral triangle, you take any two equilateral triangle, they are all similar. The angles are all 60 degree, 60, 60, 60. In any triangle, if you see, the angle is 60, and the side, this is x, all are x, here also all are. If you take polygon also, where the corresponding angles are equal and where the corresponding sides are proportional, this condition is mandatory now. If this condition holds true, then only we can say that these polygons are similar. So if the corresponding angles are equal, you see, right, this sides are corresponding angles are equal. For example, this is angle 1 and this is 1 dash. If those two angles are equal, this is 2, this is 2 dash, this is 3, this is 3 dash, this is 4, this is 4 dash, this is 5, and this is 5 dash. So if 1 is equal to 1 dash, 2 is equal to 2 dash, 3 is equal to 3 dash, 4 is equal to 4 dash, and 5 is equal to 5 dash, then we can say that these two polygons are proportional. Here if you see all are equal polygons, all the sides are equal, angles are equal, so that means both are proportional. So they are also similar figure. So these were some examples of similar figure we have seen. So in similar figure, what we've observed, the observation is, if you take triangle also, equilateral triangle, and when I'm claiming that all the equilateral triangle are similar, why? Because the corresponding angles are equal, because all the angles 60 degree in any triangle, so corresponding angles has to be equal, right? Also, if this is x, all are x, if this is y, all are y. The second condition is the corresponding side has to be proportional. So you will see, if you say this by this side, you get x by y. If you say this side by this side, you will get again x by y. If you say this side by this side, you will also get x by y. So if you see here, right, the corresponding sides are proportional. So two very important condition for any two mathematical object to be similar is, one, the corresponding angle has to be equal and the corresponding sides has to be proportional. You take any two object, if this two condition is true, that means it is similar. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.